take a look at the shell method, finding the volume using the shell method, because sometimes it's easier to find the shell method than it is the washer method. And that's basically when you rotate something and it doesn't look like a washer, like a washing machine, use the shell method because it's a lot easier. Alright, so for example 1, find the volume of the solid generated by rotating the region bounded by y equals 0, x equals 4, and y equals radical x around the line x equals 6. So this one, actually, when you rotate it, it won't look like the washers or the discs that we've been looking at in the previous videos. It's going to look different. So for that, definitely use this. So this is the line y equals 0. I'm just going to color it all. And then x equals 4 is a vertical going through 4 on the x-axis. And then radical x is a curve that looks somewhat like that. And then we're going to take that place that's bounded by all of those 3 curves, and we're going to rotate it around the line x equals 6. So you get this x-axis 6 vertical line. So you can see that if we rotate that little shape around that, we're going to get, remember, because if we did the other method, you draw the reflection, right? So it would look like, and don't draw this, just listen. So it looked like that, and when I rotate that all together, it's not going to look like a washer or a disc. So that way this method is not going to work, because you see it's going to, I don't know, it's going to have a funny shape, I don't know. Or maybe, oh, it's like an upside down washer actually. But anyway, let's go ahead and just teach you the shell method, because sometimes it's easier to use it this way. So again, I'm just going to draw everything, but just with the area that I'm interested in. This is a listening check. Underline example 1. Underline example 1. Alright, so we're taking that little area and we're rotating it around that line. Okay, so the shell method is really, really simple. Basically, it says that, you know how the other method, it was perpendicular. Well, with the shell, it's parallel. So you can see that this is parallel to the rotational line. And basically what it means is if you take that one line and you rotate it around, what shape is it going to make? It's going to make a cylinder. So if you take that one shape and you rotate it around, it's going to look like this. So this is where it comes from. The cylindrical or shell method is the same thing. So you take that one line, you rotate it. Now, very important to notice that it doesn't have it's like hollow. It doesn't have that. So what's the area of a cylinder? It has no circles. This right here is a circumference. And what's circumference? 2 pi r. And this is the height. So to find the area of the shape, it's going to be 2 pi r times height, because you don't include the circles because it's hollow. So step 1, just like before, always draw a picture. Step 2, are the rectangles perpendicular using washer or disc, or parallel using shell? So in this case, they're parallel. That line is parallel to the axis of rotation. That line is parallel to the axis of rotation. So we're going to use the shell method. Alright, then draw the image after rotation, which you know we just did, it's a cylinder. Then use the area equals 2 pi rh. You can memorize it or you can derive it the way I did, and write the integral, then evaluate it. It's really simple. So what's the radius of this? The distance from the line to the rectangle, let me call that x. So that distance there is 6 minus x. So that's the radius. The height is the height from y equals 0 to the actual curve. So height is radical x, because that's the curve, minus 0, because that's the y value, which simplifies to obviously radical x. I don't know why it's not letting me write that. Alright, so the area is 2 times pi, and the radius is 6 minus h, and the height is radical x. Now we're just going to integrate it. Now, the integral is going to go from 0 to 4. Because everything is in an x. Remember, everything is in x, everything must be in x. Of the area with respect to the x. So again, make sure when you put your functions, you open and close parentheses. So I'm just putting all my functions in and closing the parentheses. Then comma with respect to what? dx. So I'm going to put x, comma, from 0 to 4. Make sure it's separated commas, and you close the integral. Then you press enter. Again, rewind the video, make sure that you can do it, or just come and ask me. So to the nearest 3 decimal places is 120.637. No rounding on that one. It's relatively simple. The shell method is actually pretty easy. Alright, let's take a look at another example. Find the volume of the solid generated by rotating the region bounded by x equals y cubed and x equals y from 0 to 1 around the line y equals -1. And again, just a big hint, when they give it to you in terms of y's, then it's dy. If they give it to you in terms of x, it's more than likely dx. Don't quote me on that, but I'm going to go with like 90%. Alright, so I'm going to rewrite this in terms of y equals, so that's cube root of x, and then y equals x, so I can graph it from 0 to 1. Alright, so the cube root of x, and I'm just putting the values in my head, 1 gives you 1, -1 gives you -1, cube root of 8 is going to give you 2, cube root of -8 is going to give you -2. So the cube root of x looks something like this, and I know what the line y equals x looks like. It just goes through the center and has a 1-1 slope. Right, now the question is which one's on top of which, because that can get a little bit confusing. So again, for that you just plug in values. So I'll do that in a second, but let me first graph it together. So we're only interested from 0 to 1, so we don't care what happens after that. This is a listening check. Underline method in the title. Underline method in the title. Alright, so from 0 to 1, and I prematurely put that 1 there because I already know this, but you don't, I'll show you, I'll prove it to you in a second. So let me plug in a half and see what happens. When I plug in a half to y, cube that, it's going to be an 8. I plug in a half to that, the same thing is going to be a half. So which one is on top, which one is below? So what we're saying is if we go to the 1/2, go to 1/2 line on the same, on y equals x, I'm going to get 1/2. If I go to 1/2 on the cubed one, I'm going to get 1/8, which is smaller than 1/2. So that means it's above the line. So now I can just draw the cubed one on top. So I'm taking that and I am rotating around the line y equals -1. So you go to -1 on the y-axis and you draw a line. And that's where your rotation is. So yes, you could use the washer method or the disk to find this, but I'm teaching you how to do the shell. Alright, so remember, shell is parallel to the axis of rotation. Washer is perpendicular. So once I have that, you're just drawing your cylinder. So if you take that line and you rotate it, this is what you're going to get. So the radius is what it usually would be plus this little 1 over here. Listening check, color in A equals 2 pi RH. So or you could actually do the difference between the 2 points. So we can call, so the radius is going to be, let's call that y, like a y value up there. And it's going to be y minus, and then what's the y value down there? -1. Or you could look at it as 1 plus this little y there, whichever way, it gives the same answer. So y minus -1, because that's where it is on the y-axis, which is going to give me y plus 1, which I can look at as this y from 0 to y is y, and then underneath that is just 1. My height is the distance between these two curves, so it's going to be the right minus the left. Alright, so what's the right? The right is just y, or x equals y, so y, minus the one from the right, which is y cubed. Then write down my area, so area, oh actually I need to find my AB, my intervals. So you set them equal to one another and solve. So once I factor, I'm going to get 0 and 1. Because I'm only interested in, if looking at where the y is, it's not -1, so it's 1. So that's my interval. So my area is 2 pi, the radius, and the height, times the height. And now we're just going to take the integral of that from 0 to 1 of the area. So I'm just going to write all of that down with respect to dy. So let's use the calculator again. Again, math 9 is your friend, math 9. And then the functions in parentheses, so 2 pi in parentheses, then y plus 1 in parentheses, then y minus y cubed in parentheses. But because we don't have y, we're going to use x. So because we're using x, we're going to put it with respect to x. Then the interval is from 0 to 1, separated by commas. Don't forget to close it. So the nearest 3 decimal places is 2.409, because that 5 is going to make the 8 go up by 1. And that's pretty much it. So if you need to watch this video again, watch it again. Let's practice.